It's good to see you all here. My name is Kinan, and I want to tell you a little bit about my research and sort of what we do here at BU when it comes to building privacy-conscious computer and data systems. Okay, so I think I'm preaching to the crowd, but I will preach nonetheless. Digital privacy is more important than ever. I hope we can all agree on that. But just in case you don't, I'll give you some evidence. Roughly 6 in 10 Americans believe that they cannot go about their daily lives without their data being collected by some company or some entity, either directly or in some implicit ways. I happen to agree with them. Globally, 66% of consumers feel like tech companies have way too much control over their own data, and I also happen to agree with them. And this will likely only get worse as we move towards a future where everybody's wearing a smart device, everyone has like an AI, IoT device listening on everything they do, and with the proliferation of AI and what it means about data collection and data privacy. Okay, so in response to all these challenges, we as a society have decided to expect a higher bar from our applications. We expect applications nowadays to meet a variety of complex privacy policies, privacy mandates. These mandates may come from general data protection laws like the CCPA in California or the GDPR in Europe, which I'm sure you've heard about before. They might also come from domain-specific data protection laws like HIPAA or FERPA. FERPA is a federal law that governs and protects education data, so your data as students. They may also come from self-set privacy policies and terms of services. These are promises that companies themselves make to their users, but they are legally binding. You can think of them as sort of a contract. With all of that, we still find that applications constantly misuse user data. If you've been paying attention to the news, I feel like every couple of weeks, there's some news article out there that tells you about like a data breach or data abuse of some kind that some tech company has went through. And in fact, we noticed that in many, many cases, this is not because the companies are malicious or have some sort of ulterior motive. In many cases, the companies, the application developers are well-intentioned. They want to comply with the law. They want to comply with these expectations. It's just that complying with these privacy laws, privacy as a problem, is really hard. It's really challenging. And so it's really easy to make mistakes, even if the application developers are trying to comply. So let me give you a little example of this. Let's say we have a social media application. Think of your favorite social media application. I won't tell you which one, right? Okay. In this example, we have 2 users, Nell and Alice. Alice happens to be a child. And this application is governed by the following policy. It's a policy that says that children's data, specifically phone numbers and emails, should not be publicly accessible. This is a very common policy, very common requirement. It's there in the GDPR and many other laws that we spoke about before. Okay, so let me show you how this would play out in practice. Let's say Nell is scrolling through her phone, scrolling through the application, encounters Alice's profile, clicks on it. Okay, clicks on Alice's profile to view it. The way this works behind the scenes is there's a request. This doesn't work. Yep. There's a request that gets issued from Nell's phone, goes all the way to the application server. In response to this request, the application goes to the database, fetches Alice's profile, brings it back. Now, our application developers in this scenario are smart and they're careful, and they remember that policy that I showed you before, and they enforce it manually. They add some piece of code into their program, something like this if statement right here, that says, if the profile that I'm looking at right now happens to be a profile of a child, remove the email, remove the phone number, then send it to the user's device. All right, so now Nell gets Alice's profile, but she does not get the email, does not get the phone number. So far, so good. Everything's fine. No privacy violation, no problems. Unfortunately, things are more complicated in reality. So let's say later, the application developers decided, okay, let's add a new feature. Let's move fast. Let's break things. Let's add a new feature. Let's add a business profile feature. Now, some profiles can be business profiles. Maybe that gives them some kind of extra features or abilities. Okay. In response to this, Alice decides, all right, let me upgrade my profile to a business profile. Now we're going to repeat the same exercise from before. Nell, scrolling the application, clicks on Alice's profile. The same request is sent. The application fetches the data from the database. Everything is the same. But because this is a business profile, the application and its code does not remove the email and the phone number. Why might that happen? Well, maybe the application developers forgot, because this is a large application with a lot of code. Or maybe they have some kind of misguided misconception that a business profile cannot belong to a child, because why would it? In either cases, what we now have is a violation of the privacy policy and a violation of the law. Good. Now, I know what you're thinking. You're thinking, what kind of made-up example is this? Why would a child have a business profile? What's going on here? It is not made-up example. This is almost precisely what happened to Instagram a couple of years ago. And in fact, it was fined for it about $400 million very recently. I was really curious. I was like, why would children do this? Why would they get business profiles? And apparently there was a rumor, someone started, that if you have a business profile, you get to see who views your profile. And I presume everybody wanted to see if they're like high school crushes, like looking at their profile or something. I don't really know, but it's unfortunate because it did cause quite a major privacy scandal for Instagram. So I think the lesson here is that what we need to be doing is we need to be helping developers. We need to be helping these well-intentioned companies that want to comply with the law by offering them solutions, by building practical off-the-shelf systems that they can just get off the shelf, use directly to get help with enforcing the privacy policies that they have. So this was where one of my recent papers, one of my recent systems come in. I called it Sesame. And Sesame is a practical policy enforcement system targeted at web applications. And I'll tell you very, very high level how it works. So here we have an application developer. She builds an application. So she's coded some application up. Then after that, she goes and fetches Sesame from the shelf and she says, I want to run this application using Kinan's system, Sesame. And it configures Sesame by giving it a policy. For example, the policy that we've seen before. Okay. Now she lets the application run, users are using it, and as the application is running, Sesame is constantly looking at the computation, which might be really, really complicated, looking at it, analyzing everything, making sure that nothing violates the policies, and if anything even moves a little out of line, Sesame will immediately cut it down, shut it down, and ensure that no violations ever occur. This is very high level. If you're interested in details, come talk to me afterwards. I'll tell you a bit more. Okay. This problem, though, this problem of policy enforcement is an old problem. It's well known, it's challenging. People have been studying it for years, 30, 40 years. Relates to things like information flow control and many other things that are well known in our research community. So why am I visiting now? Why the resurgence of this problem? And there's really two reasons. The first reason has to do with the recent rise in memory-safe programming languages, and specifically a language called Rust. This is a newish language, but it offers many, many interesting guarantees to programmers. It offers them guarantees that their programs are safe in how they use the computer resources, how they use the computer memory. And it's been getting a lot of adoption in practice. Many companies are using it. There's this humongous DARPA project about translating legacy code to Rust. And in fact, we teach Rust in our curriculum right here. We teach it in the S210. Okay. This Rust programming language is what allows us to do the kind of interesting program analysis that allows me to build Sesame and enforce these policies. The second reason is the proliferation of AI coding agents. You probably have been reading a lot of articles about this in the past. And I like to think of this as two things. First, it's a challenge, because when an AI agent is writing code, it might hallucinate bad code. It might write bad code that is incompliant or insecure in some way. We really need tools to look at the output of the AI-generated code and analyze it, make sure that it's safe, make sure that it complies with the policy. But I also think of it as an opportunity. It's an opportunity because in the past, when humans were writing all the code, some techniques when it comes to security and privacy were deemed too impractical just because they were really tedious. They required a lot of thinking, for example, on behalf of the human developers. But if the AI is writing the code, then suddenly those tedious techniques are not so tedious anymore, and it really changes the balance and the trade-offs that we have. Okay, so let me end by telling you just a couple of quick things about privacy and data systems research and work here at CDS. First, I want to have a shameless plug for my lab, the BU Space Lab, the Systems for Privacy and Compliance Engineering Lab. I'll tell you a little bit about what kind of questions we try to answer in this lab. One of them is, how can we design and build privacy-preserving AI tools, AI assistants? Another question is, how can we enforce security and privacy policies of the kind that I showed you before in more complicated applications and distributed applications that span many microservices and cloud machines and all of that? What about using privacy-preserving technology for the public good? And finally, what about the interplay between data systems, between privacy, between public policy and law, and how do they influence each other? So there's a lot that we study in the lab. I want to highlight the students in my lab that are doing fantastic work. I can't do any of this without them. And I also want to point out that many of them are in fact undergrads, and I do really enjoy working with undergrads on research topics. Finally, I want to highlight some of our courses in this area. I already mentioned DS210, which is the intro to programming for data science that uses Rust. I'm currently designing a new course that will hit the market in the spring, very soon. It's an introduction to data systems design and implementation. We have a fantastic cryptography for data science course that Mayank teaches that goes into the theory and the practice of how we use cryptography to secure our data analytics. And there's my graduate seminar on privacy-conscious computer systems that is, I welcome all undergrad seniors and juniors mostly to take it, where we read a lot of interesting research paper and look at the state of the art in this field. And finally, if you're an undergrad at CDS and you're interested in even more experience in these things, you can always do research via directed study or via any of our programs. For example, I'm leading this Explore Data Science research program this semester that we will be doing every now and then. This is a research initiation, a way to recruit students to do research as undergrads. We have Europe in the summer not just in the summer, year round, for students who want to do research as undergrads. And then we have a lot of practicums and experiential learning that you'll hear more about via Spark that also touches on these security and privacy problems. With that, I'm done. Okay, thank you.